In this video, we are going to be talking about sequence and series. Sequences come in two forms. We have the arithmetic progression, which in short is denoted as AP, and then we have geometric progression, which in short is denoted as GP. Now, so for example, let's understand the dichotomy between arithmetic progression AP and geometric progressions GP. So let's assume we have these numbers, like for example 1, 5, 9, 13, and 17. And on the other hand, we also have numbers like 1, 2, 4, 8, 16, and 32. What can we say about these two sets of numbers? When we come to the arithmetic progression, you see that the difference between 5 and 1 is 4. And the difference between 9 and 5 is also 4. The difference between 13 and 9 is 4. And the difference between 17 and 13 is also 4. So you see that in arithmetic progression, there is a common difference. Common difference in arithmetic progression. Now let's come to the geometric progression. What's the difference between 2 and 1? It is 1. The difference between 4 and 2 is 2. And the difference between 8 and 4 is 4. And then the difference between 16 and 8 is 8. So you see that whereas there is a common difference in arithmetic progression, geometric progression does not have a common difference. However, let's look at what is 2 divided by 1. It is 2. 4 divided by 2 is also 2. 8 divided by 4 is 2. 16 divided by 8 is also 2. And 32 divided by 16 is 2. So you see that in geometric progression, we have a common ratio. So this is the major difference between an arithmetic progression and a geometric progression. In an arithmetic progression, we talk about the common difference, and in a geometric progression, we talk about a common ratio. Let's consider these numbers as well: 21, 22, 23, 24. So if we stop here, you can see that the common difference is 1. So we can continue by just looking at this. You can see that the next number is 25, and then the next one 26, and so on, by just adding the common difference to it. Let's look at these numbers. For example, 4, 16, 256. So you see that 4 squared is 16. 16 squared is 256. So by this you can know the next value by just squaring 256, and that will give you 65,536. So this is the difference between arithmetic progressions and then geometric progressions. Now let's first start with the arithmetic progression. For example, if we have an equals into bracket n minus 1 over n, what are the first 6 terms of this sequence? So the first 6 terms is from A1 to A6. So what it means is that you start putting the numbers 1, 2, 3, 4, 5, and 6 into this sequence, and then get the corresponding values of an. So what is A1? A1 is just into bracket 1 minus 1 divided by 1. and 1 minus 1 is 0. 0 divided by 1 is 0. So A1 is 0. What about A2? A2 is 2 minus 1 divided by 2. And 2 minus 1 is 1. 1 divided by 2 is 1 over 2. What about A3? A3 is 3 minus 1 divided by 3. And 3 minus 1 is 2. So this is equal to 2 divided by 3. What about A4? A4 is just insert 4 inside the sequence. So in this case, it will be 4 minus 1 divided by 4. 4 minus 1 divided by 4. And 4 minus 1 is 3. So this is equal to 3 divided by 4. And then A5 is equal to 5 minus 1 divided by 5. 5 minus 1 is 4. So this is 4 divided by 5. And then the last one, A6, is 6 minus 1 divided by 5. And 6 minus 1 is 5 divided by 5. And this is equal to 1. So now let's consider these numbers 1, 2, 3, and 4. What is A1? A1 is equal to 1. And what is A2? A2 is equal to 2. However, 2 can also be written as 1 plus 1. But we know that A1 is 1. So therefore, these 2 can also be written as A1 plus 1. Then what about A3? A3 is equal to 3. And 3 is the same as 1 plus 2. And this is equal to 1 is A1. So this is equal to A1 plus 2. Then A4 is equal to 4. 4 can be written as 1 plus 3. And then 1 is A1. So this is the same as A1 plus 3. However, you see that this 2 can also be written as 1 times A1 plus 1 times 2. And this can also be written as A1 plus 1 times 3. So this 1 that keeps repeating in successive terms is what is known as the common difference. And therefore, this can be written as A1 plus D for the common difference. And this is equal to A1 plus 2D. And this is equal to A1 plus 3D. So you can move directly from A1 to A4 by just using A1 plus 3 times the common difference. You find the common difference by subtracting the next term from the previous term. So we have a question here. It says that show that the following sequence is an arithmetic sequence. Find the first term and then the common difference. So the sequence Sn equals into bracket 3n plus 5. We are supposed to show that this is an arithmetic sequence. So let's find S1. S1, we insert 1 here, so it will be 3 times 1 plus 5. And this is equal to 3 times 1 is 3 plus 5 is 8. S2 is equal to 3 times 2 plus 5. 3 times 2 is 6 plus 5 is 11. S3 is equal to 3 times 3 plus 5. 3 times 3 is 9 plus 5 is equal to 14. And then S4 is equal to 3 times 4 plus 5. 3 times 4 is 12. 12 plus 5 is equal to 17. So you see that the terms of the sequence is 8, 11, 14, and 17. So what is the first term? A1 is equal to 8. And what is the common difference? The common difference is the next term minus the previous term. So if you take this, it's going to be 11 minus 8, and 11 minus 8 is equal to 3. So in this case, the first term is 8, and then the common difference is 3. Now, we also have another question here. It said that we should show that the sequence Tn equals into bracket 4 minus n is an arithmetic sequence. Find the first term and the common difference. So this one too is the same thing. We need to just find the first few members of this sequence. So let's find T1. This is equal to 4 minus 1, and that is 3. T2 is equal to 4 minus 2. 4 minus 2 is equal to 2. T3 is equal to 4 minus 3. 4 minus 3 is equal to 1. T4 is equal to 4 minus 4, which is equal to 0. So the members of the sequence are 0, 1. Sorry. The members of the sequence are 3, 2, 1, and 0. So what is the general formula for an arithmetic sequence? So we said A1 is equal to A. So let's say the first term is A, and then the second term A2 is equal to A1 plus D. And then the third term A3 is equal to A1 plus 2D. And then the fourth term A4 is equal to A1 plus 3D. And then A5 is equal to A1 plus 4D. So you can see that the nth term an is equal to an minus 1 plus d. That is, the nth term is the last but one term plus the common difference. So now let's find the last but one term, which is an minus 1. So an minus 1 is the last but one term to an minus 1 plus the common difference. And the last but one term in that case is going to be an minus 2 plus the common difference d. So in terms of A1, an minus 1 is equal to A1, which is the first term, plus n minus 2 times the common difference. So if this is the last but one term, then what is the last term? The last term an is the last but one term plus the common difference, as we have established in this case. So this is equal to the last but one term, which is A1 plus into bracket n minus 2d, then plus the common difference plus d. So an is equal to, removing the bracket, that will be A1 plus nd minus 2d plus d. So an is equal to A1 plus nd minus 2d plus d will become minus d. So let's factorize my d out. So it becomes an equals A1, then plus into bracket n minus 1d. So this is the formula for finding the nth term of an arithmetic sequence. So we have an equals A1, the first term, plus n minus 1d. So for example, if we are supposed to find A7 will be equal to A1 plus, then you replace the n with 7. That will be 7 minus 1d. So this is equal to A1 plus 7 minus 1 is 6, so 6d. Then we have, let's find A20. A20 will be A1 plus, then n is 20, so 20 minus 1d. So A20 is equal to A1 plus 19d. So let's solve this question. Let's take this sequence, which is 2, 6, 10, 14, and 18. The question says that we should find the 41st term of this sequence. An is equal to A1 plus into bracket n minus 1d. So we know from this sequence that A1 is equal to the first term, which is 2, and then the common difference d is the number minus its previous number. So in this case, it's going to be 6 minus 2, which is equal to 4. So now let's write A41. A41 is equal to A1 plus n in this case is 41 minus 1d. So A41 is equal to A1 plus 41 minus 1 is 40d. But we know the value of A1 and d, so we can insert it. So A41 is equal to A1 is 2 plus 40 times d is 4. So this is equal to 2 plus 40 times 4 is 160. So 2 plus 160 is 162. The eighth term of an arithmetic sequence is 75, and the 20th term is 39. A. Find the first term and the common difference. And then B. What is the nth term of the sequence? So let's write the general formula for finding the nth term of a sequence. An is equal to A1 plus into bracket n minus 1d. So he says that the eighth term. So let's find A8. A8 is equal to A1 plus n is 8, so that will be 8 minus 1d. And A8 is equal to A1 plus 8 minus 1 is 7, so 7d. So the eighth term is 75. So all of this must be equal to 75. So this implies that A1 plus 7d is equal to 75. And this is our equation 1. Then he also says, the question also says the 20th term. So the 20th term is A20. So let's write the formula for A20. That will be A1 plus n is 20 minus 1d. So A20 is equal to A1 plus 20 minus 1 is 19d. And he says that 20th term is equal to 39. So this implies that A1 plus 19d is equal to 39. This is our equation 2. So let's take equation 1 and equation 2 and solve them simultaneously to find the first term and the common difference. So let me write equation 1 down here. Equation 1 is A1 plus 7d is equal to 75. So this is equation 1. So you see that there is A1 here and there is also A1 here. If we subtract equation 1 from equation 2, then we can get rid of A1, and therefore it will only remain with D. So equation 2 minus 1 is A1 minus A1 then plus 19d minus 7d equals 39 minus 75. So a1 minus a1 is 0. 19d minus 7d is 12d equals 39 minus 75 is minus 36. So we can divide through by 12 and divide this side 2 by 12. So this 12 and this 12 cancels out, and d is equal to minus 36 divided by 12 is minus 3. So now that we found d to be minus 3, let's put that value into equation 1 to find the value of a. So now that we have found d to be minus 3, let's put d equals minus 3 into equation 2 to find the value of d. So a1 plus 19d, and d is minus 3, equals 39. a1 is equal to 39 minus 19 times minus 3. So a1 is equal to 96. So we have the first term as 96, and we have the common difference as minus 3. The last part of the question says we should find the nth term of the sequence. So an is equal to, remember the formula we wrote, a1 plus n minus 1d. And what is a1? a1 is 96. Then plus into bracket n minus 1. Then the common difference we found as minus 3. So times minus 3. So an is equal to 96. The minus 3 times n becomes minus 3n. The minus 3 plus minus 3 times minus 1 becomes plus 3. So an is equal to 96 plus 3 equals 99. So 99 minus 3n. So that is the nth term of the sequence. At this point, let us find the general formula for finding the sum of an arithmetic sequence. So for example, how do you sum numbers from 1, 2, 3, 4, 5 up to 100? If you are supposed to sum 1 to 100, what will be the value? So in summing 1 to 100, so it is 1 plus 2 plus 3 plus 4 plus 5 plus up to 100. Now what we must do is, so let's say the sum Sn is equal to the sum of 1 to 100. What we must do is that we can also say Sn is equal to, instead of summing 1 to 100, we can sum it in the reverse form, which is summing from 100 to 1. So in this case, it will become 100 plus 99 plus 98 plus 97 plus 96 plus up to. So instead of just writing 100 here, I want to start from 98. So 98, then plus 99, and plus 100. So that this case will also be, so here will be 3 plus 2 plus 1. So we are summing 1 to 100, and then we are summing 100 to 1. So let's add this Sn and this Sn. So it becomes Sn plus Sn is equal to 1 plus 100 plus 2 plus 99 plus 3 plus 98 plus 4 plus 97, then plus this term, which is 5 plus 96, up to, so there's a plus here, plus into bracket 98 plus 3, and plus 99 plus 2, and plus 100 plus 1. So Sn plus Sn is 2Sn, which is equal to 1 plus 100 is 101, plus 2 plus 99 is 101, plus 3 plus 98 is 101, and plus 4 plus 97 is also 101, plus 5 plus 96 is 101, plus up to 98 plus 3 is also 101, plus 99 plus 2 is 101, and plus 100 plus 1 is 101. So you can see that it is 101 which keeps repeating itself 100 times, and therefore 2Sn is equal to 100 times of 101. So Sn is equal to 100 times 101 divided by 2, and then this is equal to Sn is equal to 50. So this is the simplest way of summing, for example, numbers from 1 to 100. So having understood this, what if we were to use the general formula of finding the nth term of an arithmetic sequence? So for example, what if it was to sum from A1 to AN? What would be the general formula? So Sn is equal to, the first term is A1, and the second term is A1 plus D, and the third term is A1 plus 2D, plus up to the last but one term, and the last but one term is A1 plus N minus 1D. Then the last term is plus A1 plus into bracket N minus 1 D. So there's a mistake here. The last but one term is A1 plus N minus 2D, and the last term is plus A1 plus N minus 1D. So this is first term, second term, third term, and then this is the last but one term, and this is the last term. So just as we did in the previous example, let us sum from the last term to the first term. So the last term is A1 plus N minus 1 into bracket D, then plus the last but one term, which is A1 plus into bracket N minus 2D, then plus dash 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 up to the last, the second term in this case is A1 plus D, and plus the last term, which is A1. So we are going to get Sn plus Sn equals A1 plus, A1 plus, so this A1 plus A1 plus into bracket N minus 1 D. So this is for the first one. Then let me put them in a bracket, plus this term, which is A1 plus D, which is this term, plus this term, which is A1 plus into bracket N minus 2D, plus up to this term, which is into bracket A1 plus into bracket N minus 2 D plus A1 plus D, then plus the last thing, plus into bracket A1 plus N minus 1 D plus A1. So Sn plus Sn is 2Sn, which is equal to A1 plus A1 is 2A1 plus N minus 1 D. So this is equal to 2A1 plus N minus 1 D in one bracket, then plus this other bracket, A1 plus A1 is 2A1, then plus N minus 2D will become plus D is N minus 1D. So this is 2A1 plus into bracket N minus 1D, then plus dash up to A1. So you see that this looks like this. This bracket looks like this bracket. So it becomes A1 plus A1 is 2A1. Then N minus 2D plus D is plus N minus 1D. It will be the same thing for the last time, which is 2A1 plus into bracket N minus 1D. So you see that this is also a certain term is beginning to repeat here, and that term is into bracket 2A1 plus, and that term is 2A1 plus into bracket N minus 1D. So the number of terms that there is, that is the number of times that this 2A1 plus N minus 1D will be repeated. So all of this repetition can be summed with M when we multiply by the total number, and therefore 2Sn is equal to N times 2A1 plus into bracket N minus 1D. So if we divide 2 by 2 and we divide here 2 by 2, these 2 and these 2 will cancel out. So Sn is equal to N over 2 times 2A1 plus into bracket N minus 1D. So this is the general formula for finding the sum of an arithmetic sequence. And then the formula for finding the nth term of an arithmetic sequence is An equals A1 plus into bracket N minus 1D. These are the two most important formulas when it comes to arithmetic sequences. So we have some numbers here which are 60 plus 64 plus 68 plus 72 plus 120. The question is, we should find the sum of, this is plus numbers in that sequence up to 120. The question is, we should find the sum of all those numbers. So what is the sum? We see that the first term, A1, is equal to 60. And then the common difference D is equal to 64 minus 60, which is equal to 4. But we know that, and then the last term was given. The last term, which is An, is equal to 120. But the formula for finding the sum, Sn, is equal to, into bracket, N over 2 into bracket 2A1 plus into bracket N minus 1D. So, but then we know that this 2A1 can also be written as Sn equals N over 2, then into bracket A1 plus A1 is 2A1 plus N minus 1D sum Sn is equal to n over 2 times the first term a1 is 60, then plus the last term, which is 120. So Sn is equal to n over 2 times 120 plus 60 equals 180. And then 180 over 2 is 90. So 90n. But we don't know the total number. However, we're given the last number, which is an. So let's write the formula for finding the nth term of a sequence to find the total number that is. Know that an is equal to a1 plus into bracket n minus 1d. An is what? 120. And then a1 is 60 plus n, which is what we are looking for, n minus 1 times the common difference. The common difference is 4. So in this case, this is equal to 120 minus 60 equals to bracket n minus 1 times 4. So times 4. 120 minus 60 is 60 equals n minus 1 times 4. So you can divide through by 4, divide here by 4. So this 4 and this 4 can cancel. So n minus 1 equals 60 divided by 4 is 15. And therefore n is equal to 15 plus 1, which is equal to 16. But remember, our sum Sn is 90n. So Sn equals 90n. So Sn equals 90 times 16. Sn is equal to 1440.